Today's video, we are going to explore 8 powerful uses of the underscore in Python. Without further ado, let's start. In Python, the humble underscore might look insignificant, but it's actually a versatile tool with several powerful uses. Whether you're a beginner or a seasoned coder, mastering the underscore can make your code cleaner, more Pythonic, and even more efficient. Let's dive into 8 practical ways to use it like a pro. The first use case of the underscore is to use it to store the last evaluated expression in a Python interactive shell. So if I open the Python interactive shell, in my case, I have installed Python 3.13.9, which is one of the Python latest version. If I perform a simple operation like 10 multiplied by 10, we can reference the last result, which is 100, with just typing the underscore. And as you can see here, we don't have to retype the last result, which comes really handy when performing quick calculations or even testing code in the Python interactive shell. The second use case of the underscore is to make large numbers easy to read. So for example, if we have a lottery prize stored in a price variable, and for example is 12,500,000 euros, which comes difficult to read this number, we can just use the underscore to simplify the readability. And as you can see here, it becomes really easy. And for example, if we have an decimal number, which is this one, at a first glance, we cannot count how many F's are present here. So let's use again the underscore to enhance the readability. And finally, a common use case is to use it with very large numbers, for example, the US debt, no? So let us use again the underscore to enhance the readability of this number. The underscore is free, so whenever you have large numbers, don't hesitate to use it. And then a question for you. Do you think if we now print all these variables in our console, the underscore remain in place, or we just use the underscore in the console and then disappears when we print it in the terminal? Well, let's see. Let's print these numbers, and as you can see here, the underscore disappears. The underscore, what it does is just enhances the readability, but Python ignores when we execute our program. The third use case of the underscore is to use it as a throwaway variable. In loops, when the name of the variable isn't needed, the underscore comes handy to use it as a placeholder. Imagine we want to print 5 random numbers between 0 and 100, and as you will see, we will use a for loop, but we won't take care about the name of the variable. We will just use the underscore. For example, if we just import the random module, and then we just use a list comprehension to store 5 random numbers that go from 0 to 100. We just use the underscore here to just ignore the name of the variable and to focus exclusively in the numbers. Okay, and we print this result. We have 5 random numbers between 0 and 100, and to focus here is to use the underscore as a placeholder in 4 while loops to ignore the name of the variable. The fourth use case of the underscore is to use it when to ignore certain values when unpacking lists or tuples. Imagine we have a tuple with some names, for example, Jaume, Nadia, Lisa, and Tom. And imagine that just Jaume and Elisa are athletes. So we can just use two variables, athlete 1 and athlete 2, and ignore the rest, Nadia and Tom, since we don't take care about them. So we just use the underscore here to ignore the names of Nadia and Tom since they are not athletes. We just don't use another variable, no athletes, because it's not necessary. We just using the underscore, it's enough. So if we just print now athlete 1 and athlete 2, we will get the Jaume and Elisa names, and the rest are being ignored since we are not printing them and they are not stored in any variable because we are using the underscore. The fifth use case of the underscore is to use it when a variable name conflicts with a Python keyword. As you may know, def is used to define functions in Python, but what if you want to use it when defining a variable? So you just have to add the underscore at the end. For example, here in the class is the same. If we had the try, it will be the same, because if we don't add here the underscore, Python will throw a syntax error since try is reserved as a Python keyword for try except blocks. The sixth use case of the underscore is to use it as a leading underscore when defining variables for internal use in classes. Here we have defined a counter class that implements a simple counter with protector variables and methods using the underscore. As you can see, the functionality of this class is very simple. It initializes a counter with 0, then we have a method that adds 1 to this counter, then a method that returns the value of this count, and finally an internal method that resets the count to 0. As you can see here, the internal variables, the convention is to use the leading underscore to define as a internal variable to not be accessed. However, if we can just call these methods and these variables, we can access the count variable and print the numbers. And as you can see here, the leading underscore is just for internal use, but in reality, you can access the value and the methods from it. In the next use case, we will see how can we use the underscore to disallow accessing the variable or the method. The use case of the underscore is to use it when accessing or defining private variables in classes and subclasses. Here we have a small example. We have a class car that defines an attribute self-engine number and a getter getEngine number. And then we have a subclass sports car also set self-engine number. The double leading underscore is not true privacy, which means that is name mangling, that Python rewrites engine number internally to include the class name, so subclasses and outside code don't clash with the same attribute name. Now we are gonna run the script and you will see what happens, because here we are trying to access a private attribute. So let's run the script. And as you can see here, we have an attribute error because the attribute name is mangled. Instead, we have to call the getter method to get the value of the attribute. So let's see, if we comment this line and we run again, you will see that exactly if we just invoke the getter method, we can access the mangled attribute. Then you can still access the values if you know the mangled names. So here, for example, we are accessing the attribute because we prior know the mangled name. So this is a way to access also the private variables. And as you can see here, the private variables are not safe at all. So if someone knows the mangle name, can access it. So we use more the mangle names, the double leading underscore, when we need to avoid some name clashes in subclasses. So the takeaway here is to use the single underscore, the single leading underscore for internal use. It is the convention. And then to use the double underscore if you need to avoid name clashes in subclasses. And take in mind that is useful to avoid relying on mangling to hide sensitive data. The final use case of the underscore is to use it when defining Dunder methods or magic methods in Python. Magic methods or Dunder methods are special methods with double underscores that they let you define objects that behave like built-ins. So here is a simple class animal that implements the init, the string, the len, and the equal dunder methods. So let's start with the beginning. We just define two attributes, the name and the species which the animal belongs to. The first dunder method defined with double leading and trailing underscore is the string method, which controls the string representation of the class returned by print and calling the string built-in function. In this class, it returns a readable sentence. So for example, here I define a pet, which is my pet, whose name is Mimi and it's a cat. So if I just print my pet, so we'll see that Mimi is a cat is the output of the string dunder method. There's also the rep dunder method that I'm sure that you will have seen it before, that represents the animal instance class, but for an ambiguous developer focused representation. You can also it and extends this class. Then we have the length method that lets instances respond to the built-in len function. In this case here we just want to return the length of the name of the animal. So for example, if we just print here the length of my pet, you will see that we are just returning 4, which is the length of the animal name, not the species name. If we would like to return the length of the species name, we have just to change this and we are returning 3 since cat has only 3 letters. And finally, the equal method, which means that defines equality with the double equal sign. The example first checks the other object if it's an animal with the easy instant function and then compares just the species, not the name. So if two animals belong to the same species, it will return true, otherwise it will return false, regardless of the name of the animal. So let's try this Dunder method. In this case, I've just defined a pet from Tom, which is an animal snake, whose name is Olivia. And we are gonna print this out, and you will see that in this case, we are gonna get false since the species are not the same, snake and cat. But what if Mimi was a snake? We'll get true, as you see here, because they belong to the same species. And you can also extend this part, for example, and instead of comparing species, you could compare names, you can compare both at the same time, or even if you had another attribute here, for example, age, you could compare the age. So in the takeaway here is to use the under the underscore when defining magic methods, which in Python classes there are a lot and they come really handy because they act as built-ins in Python. So we have just seen 8 powerful use cases of the underscore in Python. Remember, you can make your code cleaner and more efficient using the underscore with the last use value, number formatting, unimportant variables, unpacking tuple values, reserved names, protected variables, private variables, and Dunder methods. So next time you encounter an underscore in Python, remember it's not just a symbol. It's your secret weapon for cleaner, more Pythonic and readable code.